Space is vast. It's filled with stars, planets, and galaxies. But it also holds mysteries. One of the most captivating is the black hole. Imagine a place where gravity is so strong that nothing, not even light, can escape. That's a black hole. They are regions of space-time where gravity's pull is inescapable, warping the fabric of the cosmos. Black holes challenge our understanding of physics and the universe. Black holes are not empty spaces. They are incredibly dense objects formed from the remnants of massive stars. Their existence was predicted by Einstein's theory of general relativity. Despite decades of research, much about black holes remains unknown. They are a testament to the extraordinary forces at play in our universe. Stars are immense balls of burning gas. Their immense gravity holds them together. But when a massive star runs out of fuel, it can no longer support its own weight. The core collapses inward, and the star explodes in a supernova, a brilliant and catastrophic event. If the star's core is massive enough, the collapse continues unabated. Gravity overwhelms all other forces, compressing the core into an infinitely small point. This point is called a singularity. The singularity lies at the heart of every black hole, a region where the laws of physics as we know them break down. Surrounding the singularity is an invisible boundary known as the event horizon. The event horizon marks the point of no return. Once something crosses this boundary, it can never escape the black hole's gravitational pull. Not even light, the fastest thing in the universe, can outrun a black hole's grasp once it crosses the event horizon. As an object approaches the event horizon, time itself slows down. This phenomenon, known as time dilation, is a consequence of Einstein's theory of relativity. To an outside observer, an object falling into a black hole would appear to slow down and eventually freeze at the event horizon, its image forever redshifted. Speculations and theories. Journey to the singularity. What lies beyond the event horizon? No one knows for sure. Our current understanding of physics breaks down at the singularity. Some theories suggest that matter is crushed into an infinitely small point at the singularity. Others propose that the singularity is a gateway to other universes or dimensions. Some scientists believe that black holes could hold the key to understanding the fundamental nature of space and time. The extreme conditions near a black hole could reveal new laws of physics that govern the universe at its most fundamental level. Wormholes and time warps. Imagination runs wild. Perhaps the most intriguing possibility is that black holes could be wormholes. Wormholes are theoretical tunnels that connect different points in space-time. They could potentially allow for faster-than-light travel or even time travel. While the idea of wormholes is fascinating, it remains highly speculative. There is currently no observational evidence to support their existence. However, the possibility of wormholes continues to capture the imagination of scientists and science fiction enthusiasts alike. Mysteries of the universe. Black holes as cosmic enigmas. Black holes are among the most awe-inspiring and mysterious objects in the cosmos. They represent the limits of our current understanding of physics and the universe. Their extreme gravity warps space-time, creates mind-bending phenomena like time dilation, and potentially holds secrets to the universe's origins and ultimate fate. As we continue to explore the universe, black holes will undoubtedly continue to captivate our imaginations and challenge our understanding of the cosmos. They are a reminder of the vastness of the unknown and the incredible forces at play in the universe we inhabit.